Okay, um, we'll get started then. Um, it is week 7, Monday, so another week, and we will continue on. I will post a homework assignment today that will cover some classes and methods. Most of it should be pretty straightforward. The last bit where you're going to have to do some stuff with poker hands and stuff might be a little bit challenging, and that'll be based off of today's lecture. So today we're looking at classes and inheritance. Okay, so inheritance is the idea that you can define a new class that is a modified version of an existing class. Okay, so we talked about classes and methods on Friday, and we saw some neat things that you can do. Um, and then today we'll talk about defining related classes with the concept of inheritance. Okay, and so what we're going to do is we're going to develop a class to represent playing cards, and then a class to represent a deck of cards, and then a class to represent a hand of cards. Okay, so so I'm hoping you guys are familiar with a standard playing deck. There are 52 cards in a deck. Sometimes we call this a French deck. And in this deck you have 4 suits: spades, hearts, diamonds, and clubs. And that's kind of the order. The suits, if you play bridge, spades being I guess the most powerful suit, and clubs being the weakest of the suits. And and then each suit has 13 ranks, okay, which goes ace through king. Okay, you've got 13 ranks, and I guess depending on the game, ace can be the lowest or the highest. Okay, um, if you define a new object, what we can do is we can define a new object to represent a playing card. Okay, and if that's the case, then the attributes that we would want in our object will be the rank and the suit, because those are pretty much the 2 attributes of a card. But how we should store the attributes, that's not exactly obvious. So one idea is you just store them as strings, right? You can say spades, hearts, diamonds, and clubs. But if you do that, then it will be difficult to kind of make comparisons, right? If you say which is greater, spades or hearts or whatever, then it's going to be just using alphabetical order. Now, coincidentally, these were the suits are in reverse alphabetical order, but you know, that might not necessarily be the case. But then if you do the ranks, okay, with Jack, Queen, and King and Ace, those are not in alphabetical order, and if you use strings to represent those, then we're going to get run into a little trouble, right? So what we can do is we can kind of encode the suits as integers. Say clubs being the lowest ranked, we'll give it 0. Diamonds will be 1, hearts 2, and spades 3. And then as far as the values go, we can use the numeric values themselves, and then we'll say jacks are 11, queens are 12, and kings 13, and we'll put ace as 1. Something happened. Okay, oh, sorry, this needs to be its own slide. So, so what we will do is we will define our class right here, class card. And when you do class card, we will define the initialization, the init method, okay? And all methods inside a class, the first argument is self. We're going to say give the default suit to be clubs and the default rank to be 2, the 2 of clubs, traditionally considered the weakest card in the deck. and then and we will use we will take the suit and the rank and assign them to attributes in the card. So that will be self.suit is suit, self.rank is rank. Okay, so the default is 2 of clubs. If we wanted to create a card, say the Queen of Diamonds, we would take we would define suit to be 1, diamonds is ranked 1, and rank 12 for the queen. Okay. The only unfortunate thing is that we want to also make the cards to be read easily by humans. So we need a way to go from the integer codes, the like the 1, which represents diamonds. We need it to go back to the suits and the ranks. So what we'll do is we'll create a list of names, and then we'll define the string method to represent the cards. Okay. So inside class card, we will do we have the initialization method, and then I've got 2 lists here. I've got a list of suit names, clubs, diamonds, hearts, and spades, and then the rank names, which go from ace through king. Now I have a none because what I want is the index to kind of correspond to the rank. So if the index is 1, we want it to be an ace, and there's no card with a none. And then so what we do is we are going to return basically using the format operator, whatever thing it is, string. So it'll be like ace of clubs or 10 of hearts. Okay, that's how we read our cards. Okay, so we're going to use the format operator with a tuple which contains basically the self.rank and the self.suit. Okay. And notice what I'm doing here is I do card.rank names, which is this list, and we're going to subset it to self.rank. So if the rank is at 2, we're going to go to rank names, card.rank names, and go to index 2, and it will say 2. And then if the suit is 0, we're going to go to card.suit names and go to index 0, and that will return 2 of clubs. Okay. These variables, suit names and rank names, they are defined inside the class. They're not part of any method. These are called class attributes because they are associated with the class card. Note that they are not preceded by self.suit names or self.rank names. Okay, they are associated with the card, so they are going to be you refer to them using card.rank names, okay, and card.suit names. Whereas these attributes, say suit is 0, rank 2, those get stored as self.suit and self.rank. These are known as instance attributes because they are associated with a particular instance. So when you have a card, the 2 of clubs, they have self.suit and self.rank stored as 0 and 2. But these things, the suit names and the rank names, are common to all things that are of class card. Okay, and I've already explained why we have a none there. I guess it doesn't fit. Okay. So here I can define a card. We'll call card 2, 11, and then when I call print on it, it's going to ask for the string representation of the card, and it produces Jack of Hearts. Okay. So that works. Okay. All right. There are more methods. So Python, one of the reasons why Python is so cool is because of these special methods, and we'll see how much time we have in the course. But I might take a chapter out of a more advanced Python programming book called Fluent Python, which talks about some of these special operators, which are cool. But anyway, okay, let's talk about making comparisons. So we're already familiar with greater than, less than, and equal to for making comparisons between strings and integers and floats and things like that. Okay. When you define your own class, you can use a method double under LT for less than. Okay. And this creates a way to make comparisons between objects, and then it will get used in other methods like in other functions like sort and things like that. So just arbitrarily, as far as ranking the cards goes, we're going to rank the suits as more important than the ranks. Okay, so we'll choose suits as more important than ranks. So that means all the spades will outrank all the diamonds. So that will mean the 2 of spades is more powerful than, say, like the 10 of hearts or diamonds or whatever it is. Okay, and to perform the comparison, we can use tuple comparison. Right. So here, all I do is I expand my class definition of card, and I add the special method LT. Okay. And again, what we're doing is we're comparing 2 objects. So we've got a self and an other. And we're going to create the first tuple. The first tuple is the suit and the rank. Okay. And then the other tuple will be the other suit and other rank. That will be tuple 2. And we can just compare, is T1 less than T2? Is the self less than another? And that will return true or false. Okay. If we arrange this self.rank comma self.suit, then all of the then it will be ranked by then it will be arranged by rank first. So all of the 2s are less than any of the 3s. Okay, but here we just arbitrarily chose suit to be more important than the rank of the card. Okay, that's just in terms of sorting, and so you could design your deck differently. Okay, so here I create a card 1, 12, which will be when we print that out, it comes back Queen of Diamonds. Here's another. Here's the Jack of Hearts. Okay, so which one is greater than the other? Okay, so is card 1, so the Queen of Diamonds is ranked lower than the Jack of Hearts because all of the diamonds are lower than the hearts. So even though the Queen directly is greater than the Jack, the diamonds are ranked lower. So Queen of the Diamonds will be less than the Jack of Hearts. Okay. All right, so we have defined our card class, okay? And now what we're going to do is we're going to use the cards to build up a deck, okay? So a deck is made up of cards. So so each deck is going to contain a list of cards as an attribute, okay? So what we're going to do is we're going to create an init method, okay? And that's going to create an attribute that generates the set of 52 cards. And then we will show the string representation of the deck, which will be a very long string that will join together. Okay. So here, to initialize a new deck, so we do class deck. We're going to initialize a new deck. Again, in itself, we start off with an empty list, and then we do for each suit and then for each range, or for each rank. Okay, so we're going to do suit and range and rank and range. What we do is we create a card which will have the card of suit comma rank. So this will go 0 through 3 for the suits, and then the range will go 1 through 13. Right, the range objects start at 1, goes up to, but does not include the last number, so it'll have the ranks 1 through 13. And then all we do is we just append that card to self.cards, right? So self.cards is a list, and we're just appending each of these cards to the to this list here. Okay, and then to represent it as a string, we're going to take all of the cards, okay, in self.cards. For each card in self.cards, all we're going to do is we're going to just create the results list. Okay, the list is empty. Okay, and so right now we're going to fill up the results with string representations of the card. Okay, because right now self.cards is a list of card objects. Okay, and we can't print that out. So what we need to do is we need to convert all of those card objects into string representations of the card objects. So we're going to ask for string of card. And then to produce one large string, you can use the join operator. Okay, and the join operator, or the join method, what that does is it's a string method, and it takes all of the objects in a list and it joins them with whatever string you want. Okay, so you can put in spaces here, a dash, a slash, whatever. Here we're going to use a new line character, and it will put in, it will join everything in the lists together here. Okay, so so here I'm going to go ahead and I'm going to just create a new deck using this, and when I do this, it's going to call the init method, and then I'm going to, on the next slide, I'm going to print out the deck. Okay, and when we print the deck, you can see how it lists. Okay, so it's ace of clubs, two of clubs, jack of clubs, queen of clubs, king of clubs, and then ace of diamonds, so on and so forth. And it doesn't fit on the screen, but there's going to be 52 new lines here, each going up to going all the way up to the king of spades. Okay, so that is so this is, you know, basically if you buy a brand new deck, it will often be arranged in this order. Maybe in a slightly different order, but usually it will be arranged by suit in order. Okay, so now what we want to do is to make the deck a little bit more useful, we're going to add several methods here. Okay, so one is we're going to create a method that removes a card from the deck and returns that thing. Okay, so that's going to be useful for something like dealing a card. Okay, so if you have a deck of cards, you can imagine kind of what you do is you deal it, and you take the card and you take it, and you're basically popping it, so that if you start off with 52 cards, after you deal it, what remains in the deck will be 51 cards, and then that card that you just dealt, or in this case we might call it pop, will go somewhere else. Okay, so as far as this goes, there's already a method that exists with lists, right? So we can just do self.cards, which is the list of 52 cards, and we can just pop the last value in the list. Okay, and then you know, in some cases, you know, you'll pick up cards and put them back into the deck. All right, and so to do that, we can just use the append method. The append method exists for lists, and so we can just say to add a card. Add a card will need to take in the argument what card to add. Okay, and then we'll do self.cards append card. Okay, and that will just add a card to the self.cards list. We can also add shuffle. All right, and in order to do this, we'll have to import the random module, but that's easy. So we'll define shuffle, which will basically just run random.shuffle, and it's going to shuffle the list self.cards. Okay, and then because we've defined the less than special method, you can perform sort operations. Okay, so with whatever cards you have left in the deck, you can then rearrange them in rank order by suit from least to greatest, and that's going to just be done using you take the list and then you run the sort method. Okay, so this is a method that exists for lists, and sort requires us to have some kind of understanding of rankings, which one is less than another, and that will be taken care of as soon as you define the special method less than. Okay, so I'm going to go ahead and just add all of those things. So we've got pop card, add card, shuffle, and sort, and and these all get added to class deck. And of course, I've also had to import the module random for this to work. Okay, so here's a new deck that we're going to create. And here we print it out, okay, Ace of Clubs all the way through King of Spades, okay. Here I can shuffle it, and I can print it out. Now, so again, when you print the deck, or when you ask for string representation of a deck, it's just a whole bunch of, it's going to be 52 lines. So here I just said, let's look at the first 100 characters, which takes me up to Queen of Hearts, but the 100th character is, I guess, the H. So we can see after I've run deck.shuffle, the arrangement of the deck is out of order, okay? And so I've asked for the first 100 cards, I print ... and then I ask for the last 100 characters, not cards, characters. And so we can see the last few cards in the deck are the 7 of Diamonds, Jack of Spades, and 10 of Hearts. Okay, and what I'm going to do next is I'm going to pop some cards, which will basically deal them, and so they're going to get dealt. When you pop, it deals out the last item in the list. Okay, I guess you could say pop 0, and it will pop the index 0 item, but here we'll deal out the last item in the list, which will be the 10 of Hearts, then the Jack of Spades, then the 7 of Diamonds. So if I pop a card from deck, I'll do deck.pop card. It gives me 10 of Hearts. Okay. If I do deck.pop card, again, it gives me Jack of Spades. And if I ask to print out what's in the deck again, now we can see that those 2 cards have been removed. And then the last 100 characters will show Queen of Spades, Jack of Diamonds, 7 of Diamonds, okay, which is what we have here, Queen of Spades, Jack of Diamonds, 7 of Diamonds, but these last 2 cards have been removed. So after popping the cards, we only have 50 cards left in the deck, and we can see that the 10 of Hearts and Jack of Spades have been removed. Okay, so that's a deck. All right. Okay, so inheritance. Now we can deal with the inheritance. Okay, inheritance allows us to define a new class. Okay, that's going to be a modified version of an existing class. And so let's say we want to create a class representation for a hand. So if you're playing cards with other people, generally you'll deal some cards out to each person. And whatever card someone is holding will be known as their hand, right? So if you're playing poker, you might deal out, I don't know, 5 cards, 2 cards, 7 cards to each person, okay? And that will be their poker hand. And then, but if you're playing bridge or spades or hearts or something, you'll deal out 13 cards to each person, okay? And that will be their hand. And so in this case, a hand is similar to a deck in that they are both collections of cards, and then they require certain operations, certain methods like adding a card or removing a card from the hand. Okay, but a hand is different from a deck. Okay, so there are operations that you will want for hands that won't make sense to have for a deck. Okay, so for example, in poker, you might want to compare 2 hands to see which one wins or something. In bridge, you might need to compute a score for a hand in order to make a bid or something. And so the fact that you have kind of the similar but different gives kind of the idea to inheritance, all right? So to define a new class that inherits from an existing class, you put the name of the existing class in parentheses, okay? So back here when we defined the deck class, we just did class deck, okay? We just did class deck like this, no parentheses. What we're going to do here is we're going to define a new class called hand, okay? And it's class hand, and then you put deck in parentheses, okay? And so this will create a new class called a hand that inherits from deck. And And right now we don't have any definitions inside the hand. Okay, we have nothing defined, but we created a new definition called hand, and this inherits from deck. All right, so when you do that, that's going to indicate that hand inherits from deck. And so that means you can use methods like pop card and add cards because those have been already defined in deck. Okay, and so when a new class inherits from an existing one, the existing one is going to be called the parent class, and then the new class is called the child. Okay, if we have nothing else defined, then the hand class inherits everything, including the init method from deck, and that's not something we want, right? So what we want to do is we want to provide our own init method, and when you do that, it's going to override the init method in deck. Okay, so here we define class hand that inherits from deck, and we have an init method. And basically here, the hand also gets, we have a new attribute called a label, okay? And this will play a role later when we're talking about poker hands and stuff. But the hand will get a new attribute called a label. And as far as the cards go, which is an attribute that it inherits from the deck, we're going to make it empty. Okay. So now that we have this, the initialization. Well, actually, now that I've redefined the init method, we're basically defining the attributes ourselves. So we got self.cards, self.label, and the cards will be an empty. Okay, so when you initialize a hand, it starts off empty. All right, and so it's going to invoke this init method, and when you do this right now, hand.cards is empty. Okay, and we have not given a way for hand to be initialized with cards in it. Okay, right now we have no arguments that will say these are the cards that are going to go inside here. Okay, we have no way to kind of create a hand with cards. Okay, all we've done is right here we've created a new hand with the label new hand. Okay, and if we look at the attributes, hand.cards is empty and the label is new hand. Okay, but what we can do if we want to add a card is we can initialize a deck, and then we can pop a card from the deck called card, and then we're going to call the add card method from hand to add that card to the hand. Okay, and so so when we initialize a new deck, it's going to be in sorted order because we didn't shuffle this, and so the card that's going to get popped first is going to be the king of spades. And so when I print the hand, it consists of the one card that we dealt, which is going to be the king of spades. Right? So we didn't give a way to initialize a hand with cards in it, but we do have the add card method, and we can use this to add cards to our hand. Okay, and so I am able to add cards to my hand, but I need to use the deck to kind of pop cards, and then I can add them. Okay, so so with this in mind, we are going to create a method called move cards, and we're going to put that inside the deck class. Okay, so this method, we're going to define move cards for a deck. Okay, so it's going to take in two arguments other than self, which will be the hand that we want to move cards into and the number of cards to move into, right? So all we do is we're just going to say, you know, for range and number, so whatever number this is, we're going to repeat the same action, which is going to do to the hand, we give it the hand argument. So whatever that hand object is, we're going to call the add card method, and then we're going to pop a card, right? So we can nest this all in one line. So we're going to pop a card from the deck, and whatever card gets popped gets added to the hand. Okay, and we're going to do this many times using the for I in range. Okay, and with this move card argument, even though it's called, even though the argument is hand, okay, you can use it for any basically deck / hand type object. Okay, so so you can use cards to move basically from one hand to another hand, or from a hand to a deck, or from deck to a hand. Okay, so you can use move cards basically from one thing to another. Okay, we could call this, you know, other deck, other hand, whatever it is, and we're going to call add card. Okay, because this method exists inside the deck here. Okay, and so so inheritance, you know, is a very useful feature in that some programs would be very repetitive without inheritance, but you can write a lot more elegantly by employing inheritance. And it features code reuse. Okay, and so that means you can modify things in the parent class, and then when you kind of create new objects of the child class, it's going to inherit all of those new new features and things like that. So you don't have to keep modifying the same thing everywhere. And a lot of times it will reflect the structure of the problem, which makes the design easier to understand. Okay, but at the same time, it is possible that inheritance makes a program more difficult to read. Okay, so so sometimes when you when a method is invoked, it's not going to be clear where that method was defined, right? So here you might see right here, hand.addCard. Add card is not defined inside hand, right? So when we define hand, all we have is an init. And so, you know, in this case, we'd have to see where hand inherits from, and then we would have to look at deck. Okay. Now, and it's possible that you have quite a complex hierarchy of like several layers of parent and children classes, you know, each inheriting from different things. And so finding a particular method in some instances can be difficult to track down. Okay. But anyway, here is our class deck with everything kind of defined in it. Okay, and here's the move card method. And so here we'll create a new deck. We'll create a new hand. And from the deck, we'll call move cards into the hand. And we'll say move 5 cards into the hand. And then when I call print hand, again, the deck is initialized in order, so it's going to have the 9 through king of spades, okay, which would be a very powerful poker hand. Okay. Here we'll try this again. We'll create a new deck with new hands, and this time I'm going to shuffle the deck. Okay, and again, I'm just going to ask for the last 100 characters. All right, and so we can see it ends up with something: diamonds, 7 of spades, queen of hearts, ace of diamonds, 8 of clubs, 2 of hearts, 4 of clubs, 9 of diamonds. And then we're going to say move 5 cards. Okay, so it's going to take these 5 cards and put them into a hand. Okay, and so we can see that when we print out the hand, indeed, it has the 5 cards from the deck. And then if I ask to print out kind of the last few characters of the deck, we can see those cards have been removed, and what remains is the 7 of spades, the queen of hearts, and then all the other cards as well. Okay, so it's working, and again, this is all done via inheritance, in that when we defined our deck, it has all of these things. Okay, And notice I didn't have to redefine the class hand here. The class hand um, inherits from deck, and so when I create a new hand, it's going to inherit everything from the new deck class. Can you create a class that inherits from a class that already exists in Python, like integers? Let me think. I want to say yes. And then you can modify things. Yes, I think you can definitely create things that inherit from other types of objects. Yeah. All right. So the textbook shows some diagrams. Okay, and it's just kind of important to be able to distinguish between different class relationships. Okay, and so kind of you have has a, is a, and a dependency. Okay, so objects in one class might contain references to objects in another class, right? So we have rectangle class has a point object in it, and the deck class has cards object. Okay, so this is has a relationship in that the deck has cards contained inside. Okay, and then you might have another class that inherits from another, right? And so this will be is. So the is relationship, in that like the hand is a kind of deck, in that it inherits. So a hand inherits from deck, so a hand is a deck. Okay, it's a special version of a deck, but it is a deck. All right, and then you can also have class that depends on another, in this sense that objects in one class take objects in the second class as parameters, or use objects in the second class as part of a computation. So they might not be things that are stored as attributes, but they might they might depend on having these other objects for calculations or for some kind of parameter. Okay, and so if you again, there's the function vars, which will take whatever object is, and it will print out all the attributes. Okay, and so remember, the hand right now consists of these 5 cards: the 9 of diamonds, 4 of clubs, 2 of hearts, 8 of clubs, and ace of diamonds. And basically, if you look at this, we get a list. The cards attribute is a list of cards. And again, right now we don't have the string representation of that, but it's a card object itself, right? The card is defined inside double under main, that environment. Okay, and this is the memory location of each of these cards that have been defined. Okay, and basically the attributes of hand are the list of cards, and then the label, which is currently new hand. Okay. In your homework assignment, okay, the last homework assignment, or not the last homework assignment, but the last problem in this homework assignment, you will work with some poker hands. Okay, and the homework just appears a lot longer than it actually is, as far as things you need to do. The homework appears very long because there's a lot of test code, and there's a lot of code that has already been written for you, that I've taken from the textbook and things like that. So so you're going to define class poker hand, which inherits from hand, right? So we've created class hand, which inherits from deck. Okay, and then you're going to define something called a poker hand, which is basically a special kind of hand. And the poker hand will have certain functions where it will check itself, okay, to see if does the current hand can have a high card or a pair or two pair or a full house or whatever it might be, okay, and if it does, it's going to return true or false, okay, and so these are whatever poker hand you have, it's going to run that, and then you'll kind of add labels. Okay, so labels will be actually a list of things. So every poker hand will actually have a high card, but then from there you will add on and say, okay, this hand has a high card. It also has a pair and two pair, right? So every hand that has two pair will necessarily also have a pair inside as well. And so you'll kind of create a list of all of the labels and things. And then these code has already been written, and it will run through, and you can read through it. But what it does is it's going to simulate some poker hands by dealing cards out and then calculating basically an approximate probability of how often will you get a pair, or how often will you get a straight, and things like that. It's kind of neat, I think. But again, the homework assignment appears long because there's a lot of code, but a lot of this code you've already seen in the lecture, and a lot of it is taken straight from the textbook. So I will post this up, and that's it. That's all I got for you guys today. I have to give you the quiz answers for today, which are E for the first question, E as in elephant for the first question, and C as in cat for the second question. So E, C, elephant, cat are the quiz answers for today. Okay, we will end there, and that's it for. When is homework 4 due? Okay, I will have to assign it. I'll probably give you about a week to work on it, so probably next Monday. I'll post this up, and I'll probably make it due next Monday. So that will be that. Okay, we'll see you guys on Wednesday.